Before we begin Unit 10, here is the answer to the Unit 9 question. The best answer is choice A.
The atmosphere, hydrosphere, and geosphere make up the biosphere, and all are considered Earth's life support systems. However, the three principles of sustainability are energy flows in one direction, essential nutrient cycle, and gravity keeps the atmosphere, hydrosphere, and geosphere physically connected. Unit 10, Ecology 101.
Ecology is the science that studies how organisms interact with one another and the non-living environment of matter and energy.
You may remember learning about ecology in your high school biology class. The fields do overlap, but in general, ecologists tend to study life at the organism, population, community, ecosystem, or biosphere level, whereas biologists often focus their efforts at the organism, cellular, or molecular level.
People tend to forget that ecosystems have both living, biotic, and non-living abiotic components, such as air, water, rocks, sunlight, and minerals.
Energy is an abiotic factor that can be transferred or moved throughout an ecosystem as organisms interact with one another and their environments.
Organisms are assigned a trophic level according to how they obtain the nutrients they need.
Producers, also called autotrophs, constitute the lowest trophic level and make their own food by using energy from the sun to assimilate or use nutrients from the soil and air.
The most common example is photosynthesis, in which plants use sunlight to assimilate carbon dioxide and water to produce sugar and oxygen.
If an organism is not a producer, then it's a consumer or heterotroph.
A primary consumer or herbivore eats plants and assimilates the ingested nutrients to acquire its energy and material needs. Giraffes are a common example.
Carnivores, such as lions and eagles, are considered secondary consumers because they eat other animals in order to obtain the nutrients and energy they need.
Humans are omnivores, organisms capable of utilizing plants or animals as food sources.
Decomposers, such as bacteria and fungi, are examples of the final group of consumers that rely on wastes and remains of animals and plants for their energy needs.
Before humans came onto the scene, this incredibly efficient and sustainable system of trophic levels had been going on for a very long time.
It's important to remember that according to the principles of sustainability, nutrients are cycled in ecosystems, but energy flows in only one direction.
The second law of thermodynamics states that every time energy is transformed from one form to another, energy is diminished.
It's estimated that every time one organism feeds on another, nearly 90% of available energy is lost to the environment in each step of a trophic level.
As a result, the higher the trophic level, the more energy an organism will need. This concept will become important when we study the problems associated with feeding a population of humans that has risen well above what nature would otherwise allow.
Elements and compounds continuously move through the air, water, soil, rock, and living organisms or ecosystems in what are referred to as biogeochemical cycles.
The hydrologic or water cycle is an amazing example of a free service provided by nature.
Water is known as the universal solvent because it dissolves so many things. That's why you take a shower using water.
However, when water evaporates, it does so in pure form, so it becomes naturally cleansed or purified. The truth is that nature has many ways of purifying water.
When we examine water and wastewater treatment in a later unit, you will see that people have done nothing more than mimic nature's methods while speeding them up.
Other biogeochemical cycles worth mentioning are the carbon, nitrogen, phosphorus, and sulfur cycles. Carbon is found in all living things and is necessary for life. Organisms expel carbon in the form of carbon dioxide, and green plants use this molecule along with sunlight to produce food and oxygen.
An essential balance exists between plants, animals, and the carbon they need. You will soon understand how humans are interfering with this process. Another important biogeochemical cycle is the nitrogen cycle.
As nitrogen is the primary gas in our atmosphere and a crucial component for making life-sustaining materials, understanding and maintaining the nitrogen cycle is imperative to a sustainable future.
As an educator for sustainability, you should also familiarize yourself with the phosphorus and sulfur cycles, as these nutrients, although essential for life in certain forms, can also cause severe environmental degradation and risk to human health in others.
Unfortunately, All we were able to do for you here was introduce some basic concepts and terminology. The really important thing to remember is how interconnected everything is.
Ecology is best explored hands-on. Someone once said, "The world is a great place if you can only get outside and into it."
Regardless of your grade level or the discipline you teach, try to find a way to make a nature hike relevant to your curriculum. We're sure that both you and your students will love the experience. Here is your question for Unit 10.
Which of the following statements is false?
Choice A. Ecology is the science that studies how organisms interact with one another and the non-living environment of matter and energy.
Choice B. Energy is an abiotic factor that can be transferred throughout an ecosystem as organisms interact with one another and their environments.
Choice C. Elements and compounds continuously move through the air, water, soil, rock, and living organisms or ecosystems in what are referred to as biogeochemical cycles.
Or choice D. It is estimated that every time one organism feeds on another, nearly 10% of available energy is lost to the environment in each step of a trophic level.
The answer and explanation are provided at the beginning of Unit 11.